Okay, today we're going to talk about woodworking math. When we're working in the shop or designing projects, there is some simple math that we need to be able to do. It's not super difficult, but we're going to run through it today in case you don't know how to do a certain thing that's coming up on the quiz or on the state test. We'll start with the easiest stuff and then we'll work up from there. The first thing we need to be able to do is convert a fraction into a decimal. So if you take your fraction, let's say 3/8, you get your calculator out, probably have one on your phone, type in 3 divided by 8, and it'll give you a decimal form of that fraction. And when you're setting up machines, a lot of times the adjustments will be in these decimal forms. So you need to be able to convert back and forth. The longer you do it, the more likely it is that you'll just remember, that 5/8 is 0.625 or 7/8 is 0.875 or whatever. But if you don't know how to do that or you can't remember, just divide 3 by 8 and you get your decimal for your fraction. Okay, that's the first thing you need to be able to do. The next thing we need to be able to do is reduce a fraction. So when I teach about this, I'm talking about measuring. So let's just run through that real quick. It'll be a good review on measuring. So if we take an inch here and we blow it up, this is 0, this is 1. Okay, so this would be half. And then we're going to add our 1/4 inch marks. There's our 1/4, 3/4. We add our 1/8. And our 1/16. Hopefully by now you've learned how to measure. But if you don't know how to measure, and you're looking at all these little lines, you don't know what they mean. If you can do two things, you can figure it out. I always tell students, if you can do two things, if you can count to 16, that's the first thing, and hopefully you all can do that. And the second thing is reducing a fraction. So if you don't know how to measure, and we have, let's say, this mark right here, we can count over 1, 2, 3, 4, 5, 6. It's 6 marks out of 16. Okay, now this is where the reducing the fraction comes in. In a fraction, the top number is the numerator. The bottom number is the denominator. Okay, if the numerator is even, we know that we can reduce the fraction. Okay, so 6 is even. We're going to keep it really simple when we're reducing. I know that you can find the common multiple, but we're just going to keep it simple and divide by 2. And whatever we do to the numerator, we also have to do to the denominator. I'm going to divide that by 2. Okay, and then we look at the numerator, the top number, it's odd. We know that we can't reduce it anymore, so that measurement right there is 3/8. Okay, let's do another one. Let's do this one here. Okay, so we don't know how to measure. We're going to count over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 out of 16. Okay, I'm going to look at that, and I look at the top number, the numerator, and it is even, so I know that I can reduce it. So I'm just going to divide by 2, 6 eighths. The top is still even, so I'm going to divide by 2. And I get it down to 3/4. Top is odd. I know I can't go down any further. That measurement is 3/4. Okay, so like I said, if you don't know how to measure, but you can count to 16, and you can reduce a fraction, you can figure out the measurements. Now that math I just did, you can do it in your head. So if you count up, you're sitting there at a machine or you're sitting at the tape measure, and you count, you can reduce a fraction in your head. Like you count over here and you got 10 eighths, or 10 sixteenths, excuse me. You can do it in your head. Divide by 2, 5 eighths. Okay. Alright, I think we're good on that. Okay, the next thing I want to talk about is bidding. Okay, so bids or quotes. So let's say that you have a business, a woodworking business, and somebody wants you to build something for them. Okay, they say they want you to build a kitchen table. Okay, so they come to you, they show you their design, they show you what you want. Well, they're going to expect you to give them a price or a bid or a quote. Okay, so you got to kind of figure out how to do that. So there's 2 or 3 things you need to keep in mind when giving a bid or a quote. The first thing is you need to be able to estimate your materials. Okay, you're going to have to go and buy or order wood to build that table. You're going to have stain / finish. You might have some hardware. And things like that. So you need to figure out how much wood it's going to take, what kind of stain you need to buy if you already have it, and what type of hardware and so on. So you need to figure out a material cost. The next thing you need to estimate is labor. So if you're building it yourself or you have employees, you need to estimate how long it's going to take to build that project. So let's say I'm working for myself and I know that to build a kitchen table, it's probably going to take me 20 hours for their particular design. And I know that for me to make a livable wage and to cover my costs of operating my business, I'm going to charge $40 an hour. Okay, so right now I know that I have 20 hours times $40 per hour. My labor cost is going to be $800. Okay, going back to materials. Let's say the wood, they want some ash. And I've priced out, I've called the lumber company, and I figured out how much it's going to cost to get the lumber here delivered and how much it's going to cost. And they want $450 for the lumber. The color of stain they want and the finish they want, I called and got a price on that. That's going to be $100. And they want a leaf in the table, so I've got to buy some hardware for that, and that's $120. Okay, then the third thing you need to kind of think of, besides materials and labor, is unexpected cost. We'll call it a buffer. Now for this job, it's a kitchen table. It's pretty straightforward. You're building a piece of furniture. You're probably going to deliver it to their house and put it together once it's done. But if it's a bigger job, say you're building a whole kitchen, you're doing all the cabinets, well, you kind of need to plan for the unexpected. So for this job, we probably don't need a buffer. It's pretty straightforward, but let's say we're doing a kitchen and we don't know that when they tear out the old cabinets, if the walls are going to be perfectly flush and level and plumb. So we might want to, add in a 3% buffer. Okay, if we were doing like a kitchen, so that we can cover ourselves. Maybe the delivery's far away. It's a 2-hour drive. We need to add in some time for that. You got to plan for the unexpected. Like I said, for this one, we probably don't need anything. So we go ahead and add that up. And we got $1,250, $1,350, $1,450, $1,470, if I'm doing that right off the top of my head. So I'd tell the customer, okay, I'll do your job for $1,470 delivered and everything. When you're bidding things, you want to be competitive because they're probably going to go to another company and tell them the same things and get a bid from them. But you don't want to go so low that you don't make money. If you're building a table and you end up making $5 an hour, you're not going to be in business for very long. So it's kind of a balancing act for that. But just some basic things, basic math, percentages. So if I wanted to add in that buffer, I'd take my total now, 1470, and times it by 0.03. That number there is just whatever you've come, whatever you think it needs to be based on prior jobs or whatever. You could just times that right into your total and get your new total there. But that kind of gives you an idea of some of the math involved when you're doing a bid or a quote. Okay. Next thing I want to talk about is adding and subtracting fractions. This is going to be right on the state test. This is something that you do in the shop when you're building things. You do it right on the fly, adding and subtracting fractions. So let's say we need to add up two measurements. We've got 1 3/8. And we need to add, I'm going to do simple here. I want to add 1/2. Okay. First thing we're going to do is look at the fractions. We've got to have, in order to add or subtract the fractions, we got to have a common denominator, meaning the bottom number on each fraction needs to be the same. And if it's not, we can't add or subtract them without doing a couple additional things. Now, if we had, 1 1/8 plus 3/8, our denominators were already the same. we can just add those straight across. We'd have 1 4/8. Okay, and then we look at our fraction here. We know that the top is even. We know that we can reduce that. We divide by 2. Divide by 2 just like we did earlier. And we got 1 2/4. Of course, I'm doing this the long way. Divide that by 2. Divide that by 2. We have 1.5. But if we don't have a common denominator like the one on top here, we've got to make them the same. Okay? So how can we make that 2 into an 8? We could times it by 4. Whatever we do to the bottom, we need to do to the top. So we can change this now into 4/8. And now we can add it straight across. 1, 3 plus 4 is 7. And then the 8's go straight across, 1 7/8. Okay, same thing in subtracting. Say we got 1 3/4 minus 1/2. We do not have a common denominator, so we need to make them. In order to make that 2 into a 4, we're going to times it by 2. Whatever we do to the bottom, we're going to do to the top. So now our new equation is 1 3/4 minus 2/4 equals 1 1/4. Okay, so adding and subtracting fractions, if the denominators are the same, you just add or subtract straight across. If they are different, then you've got to make them the same. You gotta times one of them. Okay. Again, not super complicated stuff, but it is a good reminder if you haven't done it in a while. There is quite a bit of math on the state test, and a lot of it is fractions. So if you can practice up on those and get really good at them, those are basically free points for you. Okay, the next thing, calculating square footage. So, Ed Woodworking, plywood, a sheet of plywood. Cost on that a lot of times will be either for the full sheet or for a certain square footage. So you need to know how to calculate that. Again, it's not super difficult, but if you haven't done it in a while, you might not remember. To calculate square footage, it's length times width. So if this is a full sheet of plywood, it's 4 feet long, or 4 feet wide, 8 feet long. 4 foot times 8 foot equals 32 square feet. Okay. Let's do another one. Let's say our piece is 3 feet wide and 6 feet long. 3 times 6, 18 feet square. Okay, not super difficult. Now, if you want to do it in inches, there's an additional step here. Okay. Let's say we're doing a smaller piece and we want to figure out the square footage. Let's say it's 16 inches by 32 inches. We can still do it. We do 16 times 32 which is 512. Okay, now that's inches squared. That's not what we're looking for here. So that's square inches. We're looking for square feet, so we need to convert that. Well, a square foot is 12 inches by 12 inches, which is equal to 144 square inches. So one square foot is equal to 144 square inches. So we need to take our square inches and divide it by 144. Which is equal to 3.55 square feet. So if you're going to do it in inches, no big deal. You just got to do the additional step of dividing your square inches by 144, which is a square foot. And so you can get your square footage. Let's do one more. Let's say this is 12 inches. And this is 92. So 12 inches times 92 inches equals 1,104 inches squared. We're going to divide that by 144, which equals 7.66 feet squared. Okay? Again, not super difficult. Just remember, if you're going to work in inches, you've got to then divide by 144 to get your square footage. If you're going to work in feet, you don't have to do that. Just times it straight across. Okay, now the last thing I want to talk about is board feet. And this is one that is probably foreign to you. Lumber, when sold, is calculated, the amount is calculated in board feet. And what board feet is, it's actually a unit of volume. Okay, it is the amount of wood that is in a 12 inch by 12 inch by 1 inch thick board. Okay, so that right there, 12 by 12 by 1, that is 1 board foot. Okay, so that works out pretty good unless your board's not 12 inches wide. Okay, or say your board's 2 inches thick and you've got a board here that's 2 inches thick and it's 6 inches wide and 10 feet long, or 120 inches. Okay, pretty hard to just eyeball it and say, okay, well that board's 6 board feet or whatever. So there's actually a formula that we can calculate the board feet, and this is one you probably ought to remember. Okay, so I'll write it up here. We're going to take our number of pieces, we're going to times it by our width in inches, and times that by our length in inches, and times it by the thickness in inches. Notice all those measurements are in inches. Okay, that's important. Times all that together, and then you divide by 144 and that'll give you your board feet. Okay, so let's do this board we have drawn right here. Again, we can't really tell how many board feet are in it by just looking at it. So we're going to go one piece times it's 6 inches wide times it's 120 inches long times 2 inches thick. So we're going to times all those out. And we get 1440. And then we're going to take that and divide it by 144. Again, that's 12 by 12. 144 square inches. So 1440 divided by 144 is 10. So that board right there is 10 board feet. Okay, so let's do another one. Say we got a board that is 8 inches wide. It's 1 inch thick. And it's 96 inches long, or 8 feet. And we want to buy 10 of these. So we're going to take our number of pieces. 10, right? We're going to times it by our width, 8. Times it by the length, 96. Times it by the thickness, 1. So we get 7,680. And we're going to divide that by 144. So we'd have 53.3 BF, or board feet. Okay, so remember this formula here. Number of pieces, width, length, thickness. All of that divided by 144. That's going to be on the state test. Okay, so then we need to figure out our costs. Because when you go to the lumber store, they're going to tell you, I'm not talking about Lowe's or Home Depot or anything like that. Okay, when you go to Lowe's or Home Depot, they have a bunch of boards on the shelf that are 8 or whatever by 96, and they're just going to have a price on them, $5.95. Okay, or they're going to sell it by the linear foot. This is where they don't care about how wide or how thick or anything like that. They're just going to sell you by the foot. So if you buy 10, if it's $1.95 a linear foot, and you buy 10 feet, it's going to be $1.95 times 10 is $19.50. Okay, that's linear feet. That doesn't account for width or thickness or anything like that. They're just saying for a foot of lumber, you're going to pay $1.95. Okay, but when you go to places that sell hardwood lumber like alder and oak and cherry and stuff that you build fine furniture out of, not 2x4s and pine and stuff like that, they're going to sell it to you by the board foot. Okay, so they'll have a price list. You know, maybe poplar, oak, cherry. And they're going to tell you, and there's different grades of lumber we'll talk about later, but let's just say cherry's $3 a foot, a board foot, and oaks $2.50, and poplars $1.90. Okay, so you take and figure out what you need, just like we did. Let's do one more just for practice. Let's say you go in and you say, hey, I need 6 pieces of cherry, 8 inches wide. I need them 10 feet long, 120 inches, and they need to be 1.5 inches thick. Maybe we're going to build that kitchen table we talked about earlier. So we got to do our calculation here. 6 pieces times 8 inches times 120 inches times 1.5 inches thick. 6 times 8 times 120 times 1.5 is 40, excuse me. And then we're going to divide that by 144. Is 60 board feet. Okay? And like I said earlier, this is cherry. So then we take that 60 board feet and we times that by 3. Should be $180. So our lumber is going to cost us $180 for this particular project or whatever we're doing. Don't forget tax too. So if I needed to figure out tax, if you're bidding a job, don't forget tax. That can cost you some money. Done that before. So you got to take your material total and then you got to add in that tax. So if our tax is, I don't know exactly what it is. I think it's 0.07. You take 180 and you times that by 0.07, which equals $12.60. So that's $192.60. That's going to cost you when you go to that lumber store or lumber mill. $12.60 on a bid. You're not gonna lose a lot of money on. But if you do a kitchen and you have $6,000 worth of material and you haven't figured in tax, it can come back and bite you pretty good. That's $420 that you weren't counting on that is now out of your pocket and in the government's pocket because you forgot about sales tax. Okay? Alright, so this is kind of the things we need to be able to do in woodworking as far as math. There are a few things we didn't cover, calculating angles and stuff like that. But I think for just basic stuff, what we covered today is good. So, if you need to practice these, take the quiz as many times as you need to. If you need help, let me know. I'm glad to help you. I can help you figure out where you're going wrong if you're not getting the right numbers or stuff like that. Okay? All right. Thanks, guys.